Hello, can you hear me?
Yeah,
Yeah.
let's start.
So let's go to the smart energy storage products, which is following of the on-grid inverters. So our energy storage system has two parts: low voltage hybrid inverters and the high voltage hybrid inverters. I remember one of our colleagues mentioned the AS1 system, and I will introduce it later. So for the low voltage part, we have H1 plus B2 low voltage batteries and AS1. Well, firstly is our H1 hybrid inverter. First, it has only single phase 3, and the power range it varies from 3 to 6 kilowatts. And because it is connected with the batteries, it had the UPS function, and it also has a 150% DC oversizing. The maximal charging and discharging current is 100 ampere. It is related to the maximal charging and discharging current of B2 low voltage batteries. And we have the string current up to 15 ampere. The naming rule. First, the H means the hybrid, and it has 3K, 3K, 3.6K, 4K, 4.6, 5, 6, and it has two MPP trackers. The H1 hybrid inverter and our B2 low voltage batteries combined to our energy storage solutions. Our B2 batteries, every battery has 5.0 kilowatt hour energy, and the LV means low voltage, and 1 means that the cells are from great power. 2 means that the cells are from EVE companies, and we could not use in one system we could not use LV1 and LV2. They could only used separately. And the maximal charging current and discharging current of the battery is 100 ampere. Besides, we could only use Pylon Tech and Dynas, this kind of batteries. And the low voltage batteries are connected in parallel. It can connect 1 to 8 batteries. So that is the energy is 5 kilowatt hour onto 40 kilowatt hour. Here is the working system of the hybrid inverters. The energy generated from the PV, it will feed the on-grid load and charge the batteries, and the surplus power will be exported to the grid. And when there is no PV, the energy used will be used from the batteries to feed the backup loads and also the on-grid loads. And we have 3 working modes for hybrid inverters, which I will introduce later. The AS1. AS1 has only one pipe, 3 kilowatts, and it is installed in AC side. That means it is installed after the inverter. It is a complementary part of the on-grid inverter. Its maximal power is 3 kilowatts, and it can, when you buy AS1, there is one low voltage battery within, and you could add up to 3 batteries. So the total energy is 15 is the total energy is 15 kilowatt hour. So you can see here. Here is the working system of the AS1. The current generated from PV is DC, and through the conversion of inverter, it becomes AC, and our AS1 can change the AC current to DC and charge the batteries, and it can also use the AC current to feed the backup load. And our AS1 inverter is compatible to almost all the inverters on the market. The 3 working mode is the self-consumption mode and time of use mode, backup mode. Except the low voltage energy storage systems, we have the H2. H2 is high voltage energy storage system. We have single phase and a 3-phase. Single phase, the power ranges from 3 to 6 kilowatts. 3-phase, the power from 5 to 10 kilowatts. It has the string current up to 16 ampere. We made a progress from the AS1 from the H1 inverter, and it has DC 150% oversizing and AC 110% overloading. DC 150% means that if we use a 10 kilowatt H2 inverter, then the maximum power of the PV panels can reach 15 kilowatts. And the 110% AC overloading means that, for example, when we use a 10 kilowatt inverter, the rated AC output power is 10 kilowatt, and it can be overloaded up to 11 kilowatts. It has single phase and 3-phase, and for both type, we have the 2 MPP trackers. So let's continue our presentation. The H2, because all the settings and the alarm informations are shown on our app and our website. So here we only use the LED light to indicating the working conditions. For example, if the battery is solid and then the battery is discharging, it's on 1 second and off 1 second, the battery is charging. And for different light, for example, the communication light, it indicates the meter communication lost, and also the BMS communication lost. And we could see all the indicator on our user menu. So because the string current of every MPP tracker of H2 is 16 ampere, so it is compatible to 182 and 120 1/3 cut. This is some advantages of the H2 inverters, which is the same as the R6. For example, DC 100% oversizing and the AC 100% overloading, and the low startup voltage and the export power. And this is our UPS function. For example, our backup load could be some family compliance, which needs constant electricity support, like computer and something. If there is no power on the grid, the inverter will switch from the on-grid side automatically and recently to backup side, and the switch time is within 10 microseconds. And here is our B2 high voltage batteries. It's the capacity is 50 ampere, and the nominal voltage is 102.4 volts, and the maximum charging and discharging current is 30 ampere. And we could also use these batteries from Pylon-Tech and Dynas. First, we could see that our B2 batteries, the 5.0 means the capacity is the 5.0 kilowatt hour, and HV means high voltage. 1 means that the cells are from great power battery, different suppliers. 3 means EVE batteries, and 5 means it's REPT batteries. They could not use together because they use different CAN communication protocol. And for the HV1 batteries from great power, we have types from A to G. Different cells from great power has different maximal current, so they could not. For example, we have the B2 HV1, but at different types. For example, type A and type G, they could not use it together. And we also have the BMS box battery control unit. The light shows shows the working mode, the working conditions of the batteries, and the number within the ring shows the remaining SOC. And for our batteries, there is a battery base. And it happens sometimes after I upgrade the software of the BMS, the ring is red and it's in breathing mode. The customer called me that it is there is an error in the system, but it is normal after it is upgrading when the ring is in breathing mode. And our battery used lithium batteries, and the maximal depth of discharge is 90%. And for H2 inverters, it can scale up to 5 batteries, that is 25 kilowatt hour. Single phase H2 can be connected with 1 to 4 batteries. For 3-phase H2, it can be connected to 2 to 5 batteries. That means for 3-phase H2 inverters, you need at least 2 batteries to start the inverter. Because these 5 batteries are connected in series, we also support expandable design. For example, we could connect 6 groups of the B2 batteries in parallel. That is 150 kilowatt hour in total. And here is the working system of the H2 inverters, which is similar to H1 inverters. Well, here we have 3 working modes. The first is self-consumption mode. That means that the energy generated from the PV panels firstly feed the on-grid load and then charge the batteries. If there's more energy, the surplus energy will export to the grid. And when there is no PV power, or the PV power is very small, firstly we use the energy stored in the battery to feed the on-grid load. We could set the discharging power. That this method is to minimize the interaction with the grid. The second is time of use mode. That it is applicable to somewhere the price of electricity is sometimes very high and sometimes very low. You can set on your app the time period when the price of the electricity on grid is very low. You could charge your batteries, and when the price becomes very high, you can use the energy stored in your battery to feed your on-grid load. The third method is the backup mode. That is, for example, when you hear from the weather forecast, or there is a announcement that there will be no power on the grid because of maintenance or repair of the grid, then you could charge your battery to, for example, a set SOC 90%, 100%, and keep it. You do not use the energy for several days until there is no grid, no power on the grid. You could use the energy to feed your loads for some days. And our H2 inverters can be connected parallel up to 10 inverters. For example, for families in Sweden, the PV powers can usually are 12 to 18 kilowatt. So our H2 inverter 10 kilowatt is not enough, and then we need to connect 2 inverters. Here is the working mode, self-consumption and time of use, and the backup mode. Then this is our star product for European markets this year, HS2 all-in-one solution. The BMS system, the battery unit, the battery control unit is integrated within the inverter. So it is light, and it reduces the installation time. The power range of the HS2 is 3 to 10 kilowatt. It has single phase and 3 phase. It is easy to install, and we have the installation video. One person could finish the installation within 30 minutes. And the other properties of the H2 inverters, like maximum 16 input current, and DC oversizing and AC oversizing, are also in HS2 inverters. And the number 5K also means the rated AC output power. Because the BMS is integrated within the inverter, so the volume is comparatively smaller, and the light is comparatively smaller. It has also AC/DC Type 2 SPD protection and AFCI. And the indication of the H2 are also shown on HS2 system. For single, and it uses the B2 batteries too. And because you could see here, it's BU2. And the above in H2 system, we use the B2 because there is the difference of control box. When you make an order, you see BU2 is it means that the batteries has no BMS box. For single phase HS2 inverter, it can take 1 to 4 batteries, and for 3-phase HS2 inverters, it must be at least 2 batteries, 2 to 5 batteries. And the batteries are also lithium batteries, and the depth of DOD is 90%. Our 3-phase batteries, 3-phase inverters support 3-phase imbalance output. That is, on each phase, we could support different power. For example, when you on one phase, the load is 1.5 kilowatt, and the other phase you have a 3 kilowatt family compliance. You don't need to export 3 kilowatt on every phase to support the loads. You could only support 3 kilowatt on this phase and 1.5 kilowatt on the other phase to save your energy. And we also have the export limitation. That means no interaction with the grid. We have 2 modes. One is the total power mode. That means the sum of 3 phase, both export and import are 0. The other is each phase power mode. That means on every phase, it's control to the on every phase there is 0 watt to the grid, because different countries has different angulation or safety regulations. For example, in Germany, they use a total power mode, and for other countries like Czech Republic, they use the each phase power mode. And the battery, single phase, it can be connected with 1 to 4 batteries. 3 phase, it can be connected with 2 to 5 batteries. And besides the system, we could also connect the battery in parallel, up to 6 groups, 150 kilowatt hour. And it has a UPS function as well. We use special connectors to simplify the installation process. We have the installation video to show how to install the system from the base to the battery to the inverter. And the connection from the inverter to the batteries are 2 sides. One is electrical connection. The other is communication connection. Here is a communication cable. On the last battery, we needed to insert an RJ45 plug to keep the communication stable. And for other batteries, port 0 to port 1, port 0 to port 1. And the power cables from the inverter to the last batteries, there is positive to positive, from negative to negative. From different batteries to batteries, positive to negative, positive to negative. Very easy to recognize. And for 3-phase, we have this plug to backup loads and the grid, or all made plug, easy to insert them. And this DC switch is to turn on the PV. This is our HS2 system. The working logic is the same as the H2 system. And it has 3 working modes too: self-consumption mode, time of use mode, backup mode. For communication, we have the communication modular 4G and the all 3-in-1. This Wi-Fi 2 is discontinued. So when we make an order, 3-in-1 communication modular is default, and the 4G is optional. We can both use Bluetooth, Wi-Fi, and the cloud connection to the inverters. That's all.